So, but maybe, and like the previous presentation, it's maybe not well connected with your discussion, your analysis, but I hope it will be helpful for you. I suppose that everybody knows that and is convinced of that. Ecosystem and poverty. Ecosystem provide a lot of basic but crucial goods like food, medicine, fresh water. They also provide important ecological services like water purification, climate regulation, of course, protection against floods. So, and the poorer communities are most affected by the degradation of ecosystems. You know that. So here you have a scheme. I won't comment the scheme, but you have a lot of services provided by the different ecosystem, and you see you have basic material for good life, health, and it's rather on these topics certainly you work on. And you know that climate change will impact the ecosystem and the services provided by these ecosystems. Before presenting some figures coming from assessment reports, I would like to present the way the climate modeling communities worked recently for the most recent assessment reports produced by the IPCC. Okay, so the IPCC is published regularly what is called assessment reports. Between 2013 and 2014, they published the fifth assessment reports, and just IPCC doesn't produce any research results. Okay, IPCC is a large community of researchers, and they just aggregate the existing papers, results. And there you have three working groups. So the first one is on physical scientific aspects of the climate system and climate change. For the working group is on the vulnerability of socioeconomic and natural systems to climate change, and the way of adapting to climate change. And for the third working group, they work on the option to reduce greenhouse gas emission. So certainly for your project, you have a lot of results, interesting things in the second report. And IPCC in 2010, not before, asked to the modeling community to be organized for the new scenarios. And the idea was to have the same assumption in the different models used to produce results on an aspect of climate change. So there are hundreds of models, of different models. It's not just socioeconomic models. So you have a lot of different models for evaluating, to evaluate yields of food, or to evaluating, I don't know, the diffusion of some health problems, and to evaluating the cost as well, the cost of climate policies. So the new scenarios, a lot of new scenarios were produced, and they identified 4 representative concentration pathways. The RCPs. These scenarios are defined in terms of radiative forcing. I will explain just a little because it's not my specialization, of course. But the radiative forcing in the year 2100 and the direction of the change. And the decision were made with the climate modeling community. So here you have four scenarios. And here it's radiative forcing. Okay, here there is a correspondence between the SCP, the number, and the concentration of the atmosphere in terms of greenhouse gas emission. So you see, it's increasing. So of course, it's better and it's catastrophic here. And you have the way of the change, the direction and change of the concentration. So here you have the concentration, a rise in the concentration. Here you have stabilization, and here you have a decline. So maybe you have seen this type of figure. Here you have the RCP, okay? And here you have the trajectories of global greenhouse gas emission. So you have different ways, different possible trajectories. So of course here you have the least increase of the temperature, the global temperature, and here the biggest increase. So you just remember this name, and you see that the trajectory of global emission are very different depending on the future we expect, we suppose we will build. You have the name at each time, and it's very important information to look for. And here you have the global average surface temperature change. So it's for the land, and here you have for the sea. Okay, and you see that the increase when you work with the assumption of the RCP 8.5, you have an increase of the temperature, a possible increase of an average maybe 4, and you can reach an increase of 5 or more of 5, okay? So the ultimate objective we have in the recent agreement, in Paris agreement at COP21, is to limit the increase of the mean global temperature to 2 degrees or maybe less. Okay, so if you want, you should make an average, but just here, if you want to limit, you must try to implement a scenario consistent with assumption of RCP 2.6. If you are in this scenario, it's under this ultimate objective, okay? So at each time, this information is important to see if the projection you have, the result you have, is in a world in which we succeed in limiting the temperature, or if we are in a world with a big increase in the temperature. So I propose here, of course, it's a mean. So for you have information for every regions, every countries, and here you have RCP 2.6 or RCP 8.5, and it's not the same world, of course. Here you have the average surface temperature, so more. The red is for change in the, okay, no, it's here. Sorry, no, here. So it's a very, very bad news. Okay, the red more redder. No, more it is red. It's more the temperature will be increased. You can have 7, 9 an increase of 7 or 9 degrees. Here, of course, if we limit the mean global temperature to 2 degrees around, okay, the world will be less hot, of course. Change in average precipitation. So, just I don't want to comment each figure, but I show you some figure you can find very easily in the assessment reports of IPCC. And and you have a lot of materials you can use but just it's important to understand in which type of world we have a projection, we make the evaluation. So, impact of climate change. Important for many things, but here I focus on food security, water availability, not infrastructure, but agriculture, agricultural incomes, yields rather, and of course rural areas are expected to experience major impact of this type. So, first, food production, and first, fisheries. Okay, so just to give you some picture, here you have the change in maximum catch potential. In fact, here it's a little complicated, but it doesn't come from the 5th assessment report. It comes from the number 4. And it's why the number, the name of the scenario are not the same. But it shows you the redistribution of the areas where you can have fish. Okay, so you see that there will be big changes in these areas, and here you have a big decrease in the potential catch you can have. It's for which date? Okay, the date is for 2050 around. Okay, so in 45 years. So if those countries are the activity and the food production of those countries depends a lot on the fisheries, it will be, of course, problematic. So you see that there will, here it's very impressive around Japan. So depending on the country you work on, you can have information on the possible evaluation of this type of this activity, and the possibility to the difficulty that population can have if the activity is based on this activity. I continue with the food. Here, you know that we have recent sharp changes in international food prices. So here it's just for the past, and with a big variation of food prices. The blue is for crude oil. So we know that the variation of the price of crude oil recently it's always so true, but if you compare the variation with the food price, you see that recently it was the same. So here it's in terms of observation, so you have changing yields over a recent period. You have different type of crops, and concerning the projection, here you have, it's 4 scenarios where global mean temperature increased by at least 4. So you are certainly in the scenario of the trend scenario of RCP 8.5, I suppose. It's an aggregation of results of different models. Okay. So here in fact, the bar represents the number of models, which concludes that there will be a decrease or an increase, okay? But here, when it's yellow, brown, it's rather decrease, and when it's blue, green, it's rather increase. So here it's a close future, okay? Okay. But you see that rapidly the number of models predicting big decrease is increased a lot. Okay, water availability. So I must finish, but I show you the different figure you can find in this report. Here it's for human vulnerability to climate change induced decrease of renewable groundwater resources by the 2015. So it's observation. So here is the name of the model. So where the result come from. Okay, so you can see the different areas. Other type of information, it's the change in annual stream flow. Okay. So here is rather an increase of stream flow, but you see that we observe already a big decrease in some areas of the stream flow, so it's not good for water availability. Natural disaster flooding. Here it's for yes, the end of the century. If you suppose that we won't succeed in limiting the temperature to 2 degrees, so we are in the worst scenarios. So an increase, big increase, a possible big increase of flooding in this area and here, but it's overall here. Less, oh no, it's decrease, sorry. Increase, no, okay, so increase is rather in blue. Wrong, so, okay. So, in fact, the blue is very dominant. The number of people exposed to flood. Okay, so here you have the different scenario, the RCP. And just concerning S, I didn't find a figure, and just I found a very general result from World Health Organization, and concerning the impact of climate change. And just here between 2013 and 2050, they evaluate 250,000 additional deaths per year due to climate change impacts. So it's just to give you a figure, and here a figure in terms of cost. Stop here. Thank you.
Thank you. Any questions?